Okay, so on to question number 7. Two different compounds exist having the formula N2F2. One compound is polar, whereas the other is nonpolar. Draw Lewis structures consistent with these observations. Okay, so when you write Lewis structures, I like to first try to find the total valence electrons of the compound. So in the case of N2F2, we have nitrogen, which has 5 valence electrons. And since there are 2 nitrogen atoms, 10. We multiply this by 2 and get 10. And for fluorine, each atom has 7 valence electrons, and there are 2 of them, so we have 14. And then if we add this together, we have a total of 24 valence electrons. So first, let's just write the 2 nitrogens. And I'll also show if the fluorines are on both sides, like on the same side. And now I'm just going to draw out all of my lone pairs on these terminal atoms. Okay, so if we count it out, we have 2 electrons in each bond. So I drew out 1, 2, 3, 4, 5, 6. And I also have 6 electrons as lone pairs on each of the fluorines, so I only have 12 so far. There as well. So we have 18 drawn in total. So I'm going to draw a double bond in between the 2 hydrogens, so that leaves us with 20. So I need to put 4 more electrons. So each nitrogen atom will have a lone pair. So that gives us the 24 valence electrons that we need. And you'll notice that I wrote this structure in the cis configuration, meaning that the fluorines are on the same side of the double bond. So if we remember that fluorine is way more electronegative, there's going to be a non-zero dipole moment going in the direction of the fluorines. So therefore, this compound is polar. Since the dipole moments don't cancel each other out, if anything, they're more amplified. But if I were to draw the trans configuration of this molecule, so this means that each of the fluorine groups are on opposite sides of the double bond. So let me just show one up there and one down here. If I show the dipole moments of the fluorines, they go in opposite directions and they cancel each other out. So therefore, this molecule is nonpolar. Since the dipole cancel each other out. Okay, so let's see what the junior tutor said. The nonpolar and polar Lewis structures of N2F2 are as follows. The cis isomers considered to be polar. 2 substituents are positioned on the same side. The 2 fluorine atoms cause 2 dipole moments that do not cancel each other, hence making the compounds polar. In the case of the trans isomer, two fluorine atoms are positioned on opposite sides, direction of the dipole moments cancel each other, and the resulting molecule is nonpolar. Yep, so this solution is correct.